Unit 2.2, Multiplying Monomials and Binomials. Students will be able to multiply monomials and binomials. Monomials mean it's one term, binomial means two terms. So let's just actually make a note of that. Monomial means one term, binomial means two terms. Now, what is a term? In algebra, a term is either a single number, a variable, or a number and variable multiplied together. So 5 is a term, 7 is a term, 4x is a term. For this, we need to know really quick what's the rule of exponent. When you're multiplying something that has the same base, you add the exponents. And when we're dividing something that has the same base, we subtract the exponents. So the first part of this I want to is find the product of each. So these are monomials. So what I do is I multiply the numbers. 5 times 3 is 15. Then I look at the x. That's x squared times x to the third. They're the same base. The base is the bottom. They have x. So what I do, I keep the x, the base, and then I add the exponent. So 2 plus 3 is 5. That's it. Negative 2 times 7 is negative 14. Remember, there's that invisible one there, so I say 3 plus 1 is x to the fourth. Same goes here. Negative 5 times negative 3 is a positive 15, and I know it's x. Remember that invisible one on x there, so it becomes 2 plus 1 is 3. And I have a y, which is fine. Y to the fourth times y to the third is y to the seventh. Now for D, I have 4x, everything square. Remember, this is the same thing as 4 square x square. 4 square is 16, x square is by itself. So these are my final answer. Piece of cake, right? Now, it is important to be able to use them in conjunction with the distributive property in order to multiply polynomials by binomials. So why did I let you do that? So the distributive property, most of you remember when you distribute, it goes to every single term, not just the 2x. So I say 5 times 2 is 10x, 5 times 8 is 40 plus 40, and that's my final answer. You have to take it to every term that I have. Same thing here. I won't just take the 3x to the 4x, but I'll also take it to the 7. 3 times 4 is 12. X times x is x squared. Minus 7 threes is 21. And then there's that x. That's my final answer. It goes to every term. Every term. So this becomes x times x is x squared minus 3x. That's it. And then the last one, every term, negative 2x times 3x will give me negative 6x squared plus 8x. Why is it plus? Negative 2x times negative 4. Negative times negative is a positive 8x. There you go. Now, what I want to review is the box method. Many of us seem confused with this. So when we're doing the box method, we use this for multiplying. We can do monomials and polynomials or any form of things that I need to multiply. The box method says first, in this case, I'm going to demonstrate how do we multiply x minus 3 and 2x plus 1. So the box method is I'm going to create a 2 by 2 grid because there are two terms and two terms. I'm going to create a 2 by 2 grid and place the factor on each side. So I'm going to keep the sign. This becomes x minus 3 and 2x plus 1. Okay, make a 2 by 2, put the factor in there. Then it says I'm going to multiply each factor in the rows and each column and then write the product. So this is, I'm bringing down my x minus 3 and my 2x plus 1. So each column, meaning I'm going to say 2 times x is 2x squared. 2 times negative 3 is negative 6x. 1 times x is x. And then 1 times negative 3 is negative 3. So notice how I develop what comes in these boxes. Once I do this, it says add them all together. These are my like terms, my x's. So what I'm going to do is add them together. So it becomes 2x squared plus, well, not plus since this is a minus 6x, 2x squared minus 6x plus x minus 3. These are my like terms, the ones with x that I did across. So when I put these together, it becomes 2x squared minus 5x minus 3. And this is my final answer. So let's practice and see how this. So we're going to see how this, a few examples. So the first thing I want to do is make my box. I'm going to do a 2 by 2 grid because I'm dealing with two terms in each. This becomes x plus 5, very important to keep your signs, and x plus 8. So I'm going to fill in these boxes. This becomes x squared 5x, 8x, and this is 40. Now, my 5 and my 8 are my like terms. So I'm going to rewrite this outside here where I have x squared plus 5x plus 8x plus 40. Since these are my like terms, my last step is just to combine them. 8 and 2, 10, 13x plus 40, and that's my final answer. Eventually, you won't even have to write this step. You don't, actually, right now, you don't need to write this step. I just want you to be able to see where this is coming from. Let's try one more example together, and then you're going to try the two on your own. Make a 2 by 2 grid. This is 3x plus 2 and x minus 4. So let's fill this in. 3x times x is 3x squared plus 2x minus 12x, and this is minus 8. Again, this is my like term. And I want to add these together. So I have 3x squared plus 2x minus 12x minus 8. Since these are my like terms, I'll combine them. So 2 minus 12 is minus 10x minus 8. And there you go. This is my final answer. So what I want you to do is pause the video and try C and D on your own. See if you get this. Hope you got a chance to try C and D. Let's see if we have the same answers. Did you get 6x squared minus 7x plus 2 and 3x squared minus x minus 14? Okay, check your work, see where you went wrong, if you made a mistake. If not, let's move forward. So most of the time in Algebra 2, you will see binomials that are in the form x plus a and x minus a. These commonly arises due to the frequency of these pairing. Any two binomials of this form are referred to as a conjugate. Now, let's work this out and then I will show you the shortcut after. So, again, this will be A and B. We'll be using our box method. If you like FOIL, that's fine. You can go ahead and use your FOIL. That's perfectly fine with me, okay? So, I want to write these out. So it's a 2 by 2 because I'm dealing with binomials. Keep my sign, x minus 5. This becomes x squared 5x minus 5x minus 25. Again, these are my like term. 5x take away 5x kind of cancels each other out. So I'm just going to write that back so you can see it. And then eventually I'm going to stop writing it. So these are my like term. This is a minus. So this becomes x squared. 5 minus 5 I know is 0, so I don't write that. So this becomes x squared minus 25. This is known as a difference of square. We'll talk about this later on in the unit. Let's try B and see how it works. What do you notice? Let's see. 3x plus 2, and then I have 3x minus 2. So fill this in. I have 9x squared, 6x minus 6x minus 4. These are my like terms. 6 minus 6 I know is 0, so this actually becomes 9x squared minus 4, and that's my final answer. What I want you to do is pause the video, try letter C and D. Good. Hope you had a chance to pause it and try it on your own. Remember, practice makes perfect in math. So you should have gotten something now looks like 4x squared minus 1 and x squared minus y squared. Now, the product of a binomial x plus a with its conjugate will always equal to what? So first of all, its conjugate will be x minus a. What did you notice here? What's happening between, oh sorry, what's happening here? Let's look at the first one. X plus 5, x minus 5. It became x squared minus 5, minus 25. How do you think we got this 25? Same thing here, think. How do you think we got this 4 and we got this 9? By just multiplying each other. So a conjugate, when I'm multiplying by a conjugate, it will always be whatever my first term is, which in this case is x. I will multiply it with itself, which is x squared, and it's always going to be a minus. So anything that has addition, I'm taking off. And then I multiply the last two terms by itself. So a times a will be a squared. So the conjugate will always be x squared minus a squared. So in this case, the first one, what I could have done is say x and x, so x squared, and then I say 5 times 5 is 25, and it's always, notice, it's always a minus sign in the middle. Without using the distributive property, let's see if we can do this. So x minus 4 and x plus 4, those are conjugates of each other. So I multiply the first term. X times x is x squared. I know it's going to be a minus. And then I say 4 times 4 is 16. That's it. That's my final answer. What about here? So I know it's 4x and 4x. So I have to multiply them. 4x times 4x is 16. X squared, I know it's going to be a minus, and then 3 times 3 is 9, and that's it. That's the point. And remember, this only works if these are conjugates. So in this case, it's 4x plus 3, 4x minus 3. Conjugates means every term is the same. It's just one is positive, one is negative. So which of the following represents a product of 5x minus 3 with its conjugate? So 5x minus 3, the conjugate is 5x plus 3. So I multiply it. 5x times 5x is 25x squared. So I know I have choice 2 is gone. And I know it's going to be a minus. I know 4 is gone because there's no b term. And then I say 3 times 3 is 9. So it's choice 3. That's all it is. Now it says the binomial x squared minus 36 is the result of which product? So let's see. So let's see the answer choices. What can I eliminate versus not? So I know the conjugates are going to be x minus 6, x plus 6. And remember, it has to be the same thing. So that's not going to work. 1 and 2, it's not going to work. And x minus 6, x minus 6. So the conjugate, the only choice, notice, remember when you do conjugates like up here, one is positive, one is negative. So I know automatically that's out. And I know it has to be choice number 4. So again, we'll eliminate 1 and 2 because the second terms has to be the same. Everything has to be the same in the parentheses. And we eliminate choice 2 because both of these have negatives. Remember, one has to be negative, one has to be positive. If I was to expand that, I will get x squared minus 36. So that's it for this unit. You're off on your own to go work on those practice problems. See me when you're ready for your quiz. Bye.